Okay, let's solve leak code 33 search and rotated sorted array. So we're basically given an array that was originally sorted like this one, but then it became rotated like this one. And by rotated, they mean that they took a certain pivot or index of the array, like right over here, and then they cut it in half and then swapped the portions, right? So you can basically think of this right-hand portion being swapped over to the left side over here, right? That's what happened, as you can see here, right? These two halves were put in the opposite position. And we're also given a target value, in this example, target 0, and we want to check if our array contains this value. If it does, we return the index. If it doesn't, we return -1. The most straightforward way to approach this problem is literally just check every single value. Is this our target? Is this our target? And eventually we'd get here, this is our target. And then we return the index 4. Now this is just too trivial of a solution, right? The time complexity isn't bad, it's O of n, but can we do better? In this problem, they literally tell us to find a solution that's O of log n, so obviously we can. And basically, anytime you're looking for a solution that's log n or better than linear, almost every time you're going to be looking for a binary search type solution. So since this array Array was originally rotated, can we use that to our advantage to potentially find a binary search type solution for this problem? Let's try to analyze it and see what we can find. So given that the original array was sorted, if we wanted to represent that as a graph, we would basically have a continuously increasing line. It might not necessarily be linear, but it would always be increasing, right? And then we took some pivot, like over here, and then swapped these halves around, right? So let's draw what that would look like. So let's say the left side was exclusively greater than the right side, because that's what it means by rotating the array, right? So I think this is a pretty good way to visualize the problem to kind of understand what it would look like. And you can use this to your advantage to find potential patterns that can help us find a binary search solution. So with a problem like this, you really have to break it down into discrete cases and then use those cases to form a solution. So the most obvious thing is that there are two portions of the array, right? There's a left portion and a right portion. Both independently are sorted, right? So it's like we have two halves that are sorted. And so we know that a binary search usually has 3 pointers, a left pointer, a middle pointer, and a right pointer. The left is always going to be less than or equal to the right. This is just something you kind of know from binary search. So let's say our middle value was 6 at some point, right? This means that we're in the left sorted portion of the array. So can we use that to our advantage? So let's say our target was greater than 6. In that case, we know for sure, since we're in the left sorted portion of the array, none of these values are greater than 6. Some point from then or equal to the right. This is just something you kind of know from binary search. So let's say our middle value was 6 at some point, right? This means that we're in the left sorted portion of the array. So can we use that to our advantage? So let's say our target was greater than 6. In that case, we know for sure, since we're in the left sorted portion of the array, none of these values are greater than 6. So we can basically say these are eliminated. Let's run binary search on this portion now, right? So that's pretty easy. If we know that we're in the left sorted portion and our target is greater than the middle, this is what we can do. What if our target is less than the middle value? So what if our target was less than 6? Well, these two numbers are less than 6. And these 3 numbers are less than 6. So how do we know which way to go? Do we go left or do we go right? Because we can't go both directions in a binary search. The key is to see that in our left sorted portion, the smallest value is right here, right? Or on our graph, it's right here. So if our target is even smaller than this left value, 4, in that case, we know that we don't have to search 4, we don't have to search 5, we don't have to search 6. We can run binary search over here. But if our value is greater than or equal to 4, then that means we're going to run binary search on these two values, right? It's less than 6, but it's greater than or equal to 4. So we can run binary search on these two values. We can eliminate all of these from consideration. So all of that is if we were in the left sorted portion of the array, right? Now what happens if we're in the right sorted portion of the array? Let's say our middle was 1. And let's say we knew somehow that we were in the right sorted portion of the array. What if our target was less than 1? Well, then we know we have to search the left. The only value less than 1 is right here. So we're going to search the left portion of this array. We're not going to look at 1. We're not going to look at 2 anymore. Any value to the right of 1 is greater than 1, so we don't have to look at them. We're just going to run binary search on these elements. We don't necessarily have to know where the pivot even is. We just know we have to go left. But what if our target was greater than 1? Well, then our solution could possibly be 2. It could also be any of these 4 values. So then where do we go? Again, we can use this rightmost value, or the edge basically of our array, to our advantage. So if our target is greater than 1 and it's also greater than 2, that means we can again search this left portion. We can eliminate these two from consideration. But what if the opposite is true? What if our target is greater than 1, but it's less than or equal to 2? In that case, we only have to run binary search on the right portion of 1, every value to the right of 1, meaning we can eliminate all of these from consideration. So that was a lot of discrete cases, and it might be confusing. I think it'll be a little easier to understand once we actually write the code, but I think it's also important to visualize it and actually understand what's going on before you even write a single line of code. And knowing what we just learned, let's just go through this example of the target equal to 0 and given this input array. So initially, our left pointer would be here, our right pointer would be here, our middle would be here. So how do we even know if we're in the left sorted portion or the right sorted portion? Well, the way I check is just if our middle value is greater than or equal to our left, the actual value at that index, if this is true, then that means our middle value belongs to the left sorted portion. If this wasn't true, that means our middle value is in the right sorted portion, and we would write our if statements accordingly. But knowing that we are in this left sorted portion, right, let's run through it. So our target is 0. That means our target is less than 7. So our target is less than 7. That means we could be looking here or we could be looking here. So let's compare it to 4 now. Is our target less than the leftmost value? Well, 0 is less than 4. Okay, so that means we're all good. We just have to search every value to the right of our middle value. So we can eliminate all of these. We can cross out our middle and left. Our new left is going to be here, and our new middle is going to be here. Now in this case, are we in the left sorted portion or the right sorted portion? Well, among these 3 values, the entire array is pretty much sorted. So according to our if statements, we're basically going to say that middle belongs to the left sorted portion because the entire thing is sorted. So now we compare middle to target. Well, our target is less than 1, so now we have to go left. And if we compared it to the leftmost value 0, our target is greater than or equal to that. So we don't have to check anywhere else, we only have to go left. So we can eliminate these 2 from consideration, and we're left with 1 value over here, and that's our solution. So this is kind of a visualization for it. Now let's actually look at the code to better understand what these cases are going to look like. Okay, so when you're doing binary search, first thing you do is initialize your pointer. So we have a left and we have a right. Left is going to be 0, right is going to be the length of the array minus 1. Our condition is while left is less than or equal to right, because imagine we're given an array
like this, we would have to use the wrapper class version of this. So for integer, it is integer of class. I'll post all. Hey, how's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to be teaching you guys all about J sliders in Java. And at the end of this video, we're going to create a project where we can use a slider to adjust the temperature. So let's get to be teaching you guys all about J sliders in Java. And at the end of this video, we're going to create a project where we can use a slider to adjust the temperature. So let's get into it. Before you reach the end of this video, make sure to like, comment, and subscribe so that we together can challenge and defeat the mighty YouTube algorithm. Alright everyone, so a JSlider is a GUI component that lets the user enter a value by using an adjustable sliding knob on a track. So to best demonstrate this, let's create another class to keep things organized. So go to your source folder, go to File, New, Class, and let's call this class Slider Demo. Click Finish, and then we're going to go back to our main class and create an instance of this Slider Demo class. So we're going to type Slider Demo, and we'll call this slider demo with a lowercase s equals new slider demo, parentheses, semicolon. So let's head to that class and start working here. So we're going to need a few things to import. So make sure you have these three imports: java.awt.asterisk, javax.swing.asterisk, and javax.swing.event.asterisk. Now with this class, we're going to implement the change listener interface. So next to our class definition, we're going to type implements change listener. So then with our slider, we can actually update something whenever we make a change. Now we're going to add an unimplemented method, and it's going to be state changed, but we're going to save that for the very end. First, let's work on our constructor for this slider demo class. So we'll just copy this and paste it, add a set of parentheses and a set of curly braces. Now what we'll do is actually declare a few global objects here. So the first thing is that we'll want a frame, so jFrame, and we'll call this frame. And that's it for now. Lastly, a slider, which is the, I guess, the main piece of this lesson. And we'll actually instantiate these within the constructor. We're also going to want a jPanel, so jPanel, and we'll call this panel. We'll need a label, so jLabel, label, and lastly a slider, which is the, I guess, the main piece of this lesson. So to do that, you need to declare a jslider, and we'll call this slider. All right, now going within our constructor here, we're going to instantiate these objects. So the first thing that we'll create is our frame. So frame equals new jFrame, and let's set the text to slider, but spell it right, slider demo. And then we will want to instantiate our panel because we're going to add the panel to the frame. So panel equals new jPanel. We'll instantiate our label, so label equals new jLabel, and then lastly our slider. So slider equals new jSlider, parentheses, semicolon. Okay, now with the slider, there's a few values that we can add. So with sliders, we can have a spectrum of ranges, and then we can have the user adjust a knob, and then they can enter in a value that way. So the first set of values is the minimum and the maximum set of numbers for our slider. So let's say that we want somebody to adjust a knob on a track between the numbers 0 and 100. So what we'll do for the first number, the minimum, is enter in 0, and then separate it with a comma. Then you can enter in the maximum number. So let's say 100. So maybe we're finding the temperature of maybe water, between the temperature of 0 and 100 degrees Celsius. So we're going to set a minimum of 0 and a max of 100. And now there's a third value we can add. This is the starting point for the slider. Let's say we want this to start in the middle. Well, we could say 50 for the starting point. Now, before we get ahead of ourselves, let's add everything to the frame. So first we'll add the slider to the panel, and later we're going to add the panel to the frame. So we'll start with panel.add slider. And we're also going to add the label to the panel. So panel.add label. And then frame.add panel. And then let's set the size for our frame. So frame.set size, and I like to pick 420 by 420. And then we need to set the frame to be visible. So frame.set visible true. All right, so first let's work on our slider then. So let's set the preferred size for this slider. So we type in the name of the slider, dot, and then we're going to use the set preferred size method. We're going to type in new dimension, and we're going to give a width and a height. So 400 is a decent height, width. So 400 for the width and 200 for the height's pretty decent, I would say. Let's actually see what we have so far. Okay, yeah, here's our slider then. So it's just a bar that's adjustable. There's no markings or anything, so we need to add that later. All right, now what we're going to do is add paint ticks. So slider dot set paint ticks, and within parentheses, we're going to place the word true. So let's see what this looks like now. All right, so we also need to add the tick spacing. So these are little, I want to say, notches that kind of give you an idea of the range of numbers. So what we'll type in here is slider dot set minor tick spacing. So how often do you want a notch in this slider? Let's say every 10 units, every 10 of whatever you're counting by. And in our case, it's degrees Celsius. So let's try it now. So these aren't numbered yet, but you can see about every 10, we should have at least like 10 ranges. Starting at 0, then they go all the way up to 100, and there's a little like notch here. Now we're going to set some major tick spacing, so that comes next. So I'm just going to copy this, and we're going to change a few things. So set paint track, and we want this to be true. And the next thing is set major tick space, and let's set this to 25. Okay, now after each 25 units, there's a larger tick. These are major ticks, and the small ones are minor ticks then. And now with the slider, we can actually add values to each of these major ticks. And let me show you how to do that. So I'll add that maybe right here. So what we're going to type is slider dot set paint labels, and we're going to set this to true. Now we have our numbers for each of our major ticks. Ticks, but not the minor ticks. And it gives our whole range between 0 and 100. And you can see that when we started this program, it begun like right in the middle at 50 because we set this value. This argument, the third one, to 50. The first one is the minimum, which is 0, and the second value is the maximum, which is 100. So if you adjusted these numbers, it would also adjust the numbers on our slider. Let's also change the font on here too. So maybe I'll do that next. So slider dot set font new font. I really cannot spell today. And maybe I'll give this a font of MV Bully because that's one of my favorite fonts. And then font dot plain. We don't need to do any styling. And I will pick a font size of 15. And let's see what this looks like now. Not too bad, not too bad. Looks more modern, I would say. So one trick you can do with this slider bar is that by default, this is horizontal. So we could actually change this to a vertical slider bar, and that kind of resembles a thermometer since we're taking the temperature. So in order to change that to vertical then, type the name of the slider, dot, set, orientation. And then within here, we're going to type swing constants, and then dot vertical. And let's take a look. Yeah, I would say that would fit a thermometer of sorts. Then if you want to change it back, it's going to be the same process, but change vertical to horizontal. And this is what we had previously, but I think for this demonstration, I'm going to keep it as vertical, but I'll just turn this into a comment just so you have it for your notes. All right, let's add a label. So we'll have a label underneath that will display the current temperature, whatever this is set to. So let's add that right underneath our slider, but before we add everything to our panel and our frame. Now to set the text for the label, type in the name of the label, and we're going to use the set text function, and then we're going to change the text. So I'm going to insert the degree symbol. I actually don't know how to do this normally, so I copied it from Google. Then degree label, and we're going to use the set text function. And then we're going to change the text. So I'm going to insert the degree symbol. I actually don't know how to do this normally, so I copied it from Google. Then degrees C equals, and then if we want to retrieve what the current value of the slider is set to, we can add plus slider, and we'll use the get value function of the slider. All right, let's take a look at this now. So it says it's set to 50 degrees Celsius, but I think I'm going to increase the font. So I'm just going to copy this, paste it, and change slider to label. And let's set this to maybe 25, so it's more visible. That's better. Okay, so it's currently set to 50, but if we adjust this number doesn't change. So I'll teach you guys how to do that. And we're going to do this within our state changed method. So what we're going to type in here is label.set text. Actually, we can just copy this and paste it. That'd probably be easier. So whenever the state changes for the slider, it's going to execute this line of code and update it. Now, the last thing that we need to do is that we need something to trigger our state changed method. So we need to add a change listener to our slider, and we can just add that here. So type in slider.add change listener, and then within parentheses, type in the word this. So this should work now. Let's try it. Okay, so the midpoint is 50 degrees Celsius. The minimum is 0, which we have here, and the max is 100. And now if we adjusted this slider, this value is also changing whenever we adjust the knob on this track. So it has a minimum of 0 and a max of 100 like we intended. And it's adjusting whenever we actually move the knob on this track then. So that's how JSliders work. It's a GUI component that lets the user enter a value by using an adjustable sliding knob on a track. So if you're looking for extra practice, your assignment is to post the code for a slider that you've made in the comments down below. But yeah, that's one of a few ways you can create a JSlider in Java. Hey, how's it going everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how J progress bars work in Java, so let's get into it. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Hey everybody, we're going to be building a progress bar, and this is defined as a visual aid to let the user know that an operation is processing. So it's It's usually good practice to let the user know what's going on behind the scenes, if something's processing, you're waiting on something. Otherwise, if there's no sort of visual cue, the user might close out of your application because they think it's frozen. So let's create a progress bar. We're going to create a new class within our project folder. So file, new class. I'll call this progress bar demo, but call it whatever you want. Click finish. Then we're going to create an instance of this within our main class. So we'll type the name of the class, and I'll call this instance just demo equals new progress bar demo. All right, so we're done with this class. Let's go back to our progress bar demo class, and we're going to import a few things. Import java.awt.asterisk and import java_x.swing.asterisk. Then let's create the constructor for this class. So we're going to type in the name of the class, followed by a set of parentheses and curly braces. And before the constructor, we're going to declare a few things. So we'll create a JFrame, and we'll call this frame equals new JFrame. And we're going to create a component called a JProgressBar. So JProgressBar, and we'll call this bar for short, equals new JProgressBar. Okay, now within the constructor, let's create the frame so we can add the bar to the frame. So frame dot set default close operation JFrame dot exit on close, and then frame dot set size pick whatever size you want. And then I usually set no layout manager. So set layout to null. Only in certain situations I like layout managers. And then we need to take our frame and set the visibility to true. Okay, now we are going to create the JProgressBar. So we're going to set the initial value first. So we're going to type bar.setValue. And if you want to start at 0, type in 0 here. Don't know why you'd want to start at a different number, but hey, maybe you can set this to 100 and count down for something. All right, then we're going to set the bounds because we're using no layout manager. So bar dot set bounds, and let's start in the top left corner. So we'll set x to 0, y to 0, and then we'll need to choose a length for this, so maybe I'll type in 420 to match the size of my frame, and then maybe maybe 50 pixels for the height. And then we need to add this bar to our frame. So we'll type in frame.add bar. And let's see what we got so far going on. Okay, we got a nice little bar here, so that's a good start. So with this progress bar, there is actually a special method. So type in bar, and this method is called set string painted, and then pass in true within here. And what this does is that it adds a percentage to your progress bar, and when you fill the progress bar or set the value, this percentage is going to change. So that's kind of cool. All right, so let's fill this progress bar. So all we really need to do is just take this bar and set the value to something else. That's like the bare minimum, I would say. But I think what we'll do is actually put this within a while loop, and we'll have the value of our progress bar increase by a certain amount every second or so. There's so many different ways is that you can create a progress bar. This is just like a basic demonstration. So let's do that within a fill method. So at the end of our constructor, we'll call a fill method, and we're going to declare this. So outside of the constructor, we'll make a public void method called fill. And what we'll do is just set the value whenever we call this. All right, so let's just set this to 10 to begin with. So when we run this, it's immediately set to 10. Now what I think we'll do is actually put this within a while loop, and we'll start at 0. So we'll create a counter. So int counter, set this equal to 0, create a while loop, and within the while loop, what we'll do is that we'll continue this while loop as long as our counter is less than or equal to 100. And we're going to take our bar and set the value to whatever our counter is. So if we want to simulate the progress bar increasing over time, we can use the thread.sleep method here. And we can set this to maybe 1000 milliseconds. So this is going to pause our program for 1 second after each iteration of the while loop. And we're going to need to surround this with a try and catch block. And then let's increase our counter, maybe by 10%. So we can say counter plus equals 10. This is the shorthand for saying counter equals counter plus 10. So let's see what happens now. All right, so it starts at 0, and it's going up by 10% every second. Almost there. All right. I think I'm going to speed this up a little bit, so maybe I'll change the counter to increment by 1% each time, and change the thread.sleep method to perhaps 50 milliseconds. So it's going to appear to go actually faster this time, and it's increasing by 1% after each iteration of the while loop. All right, we can also add some text on our bar. So maybe we'll set this after the while loop is complete. We'll display a message such as done. So we type in the name of the progress bar, set string, and then you can add some text. So maybe we'll type in done. And that should be good. So let's try it again. And then when it's finished, it says done, but it's a little difficult to see. So let's change the font of the progress bar. So if we want to change the font, we can type in bar.set font. Then within parentheses, we're going to pass in new font. Parentheses again. We can pick a font style to boys. All right, actually visitor dot color, and let's take a look. And the fill color is now red. Actually, Actually, this would be kind of cool for some sort of HP bar for a video game, but you'd probably want to start at maybe 100 and then just progress this downwards. Set back for 8 are equal with dread pre mat so many or some extend interface, and with this is just like one of a few different ways to demonstrate this concept. So if you want a copy of all this code, I'll post this in the comments down below. But yeah, that's the basics of how JProgress bars work in Java. Hey,